Hi there, thanks for tuning back in. Here we have a review problem of a pyramid. We're going to find the surface area if the height of the pyramid is 9. And you can see here that one of the base edges is 10. So our surface area formula for a pyramid is going to be 1/2 the perimeter times the slant height. And then we're also going to be adding the area of the base in there. So we need to find the perimeter of the base, the slant height, and the area of the base. So let's go ahead and draw in a triangle in one of our bases, or in the base. We're going to go ahead and draw in the height of the triangle. If we take 360 and divide it by 5 and then divide that by 2, that means our angle here is going to be 36 degrees. Since we have one side being 10, if we cut that in half, that means our distance here to here is 5. So we can actually go ahead and find the apothem here by using tangent. So we're going to use the tangent of 36 equals the opposite, which is 5, over the adjacent, which is the apothem. Solving for the apothem, we multiply by a and divide by tangent of 36 gives us 5 divided by the tangent of 36. Now that's not going to be a very nice answer. You get something that's like approximately 6.88, but we're going to go ahead and leave that stored in our calculator so that we don't have to worry about rounding differences. So now that we know the apothem, we also know that the height of the pyramid, again, is 9. So that means the distance from the apex to that center here is 9. So if you kind of imagine the apothem here, I'll draw in an orange over here, jetting out this way, here's our apothem. We actually then have a right triangle using the slant height as our hypotenuse, 9 as one of our legs, and our apothem as our other leg. So if we end up doing 9 squared plus our apothem, which we stored, squared, that's going to be our slant height squared. And so we solve that, giving us a slant height of approximately 11.33. And again, we're going to store L in our calculators so that we can use it in our formula. So now we also need to know the perimeter of our base. And so since we have 5 sides and each side length here is 10, that means our perimeter of our base should be 50. We also want to find the area of the base. So we actually have enough information to plug everything into our formula and calculate the area of the base within there. So we're going to use 1/2 of the perimeter times the slant height, which we again stored. We want the area of the base, which is going to be 1/2 of the perimeter times the apothem, which we also have stored. And so if we type all of that in on our calculator, we'll get an approximate answer of 455.29 units squared. Okay, so there is our review problem. Now we're going to dive in onto this one. We're going to find the volume and the surface area. So we're just going to go ahead and start with the volume. So we're going to need to make a plan here. So what I'm going to do is I'm going to label each part. So I have a hemisphere up here, A. I have a frustum here, which is B, a cylinder here, which is C, and a cone here, which is D. So we need to find the volume of each part, A, B, C, and D. So to find the volume of A, we're going to use the hemisphere formula, which is going to be 2/3 pi r cubed. So we're going to do 2/3 pi times our radius, which is 1 cubed. And so for part B, we are going to take the volume of that frustum. Now with that, that's going to be a little bit more challenging, so let's pause on B and we'll come right back to that, okay? Let's move on to C then. The volume of the cylinder is going to be pi r squared. Now we need to find the radius of the cylinder, and so this 20 over here is going to help us do that. Half of that means that the radius here is 10, and the radius over here also is 10. So we're going to use pi r squared times the height. And here's where, again, we have to pause. We don't know our height yet, so we'll come back to that part. And then part D here, We want the volume of that cone, so we're going to use pi r squared h divided by 3. So our radius here is 10. And we also need to find our height of our cone. And so this one's not going to be too bad. We can use the Pythagorean Theorem here. If we do 12 squared equals 10 squared plus our height squared, then we'll be able to figure out what that is. And when we do that, we ended up with a height of 2 root 11. So we're going to get 2 root 11 for our height. And so that would give us the volume of your cone. And it should be divided by 3. So now we're going to move into parts B and C. We're going to unpack that a little bit more. So let's start with this frustum because we need to know the height of that frustum so that we can find the height of the cylinder, because everything from the top of the frustum to the bottom of the cylinder together is 18. So we're going to go ahead and draw in these cones here. Now, since this radius here is 1, the other one is 10, we actually can kind of draw this in. I know it's not to scale at all, but there's a little cylinder here. This part here should be 1, which means this portion over here would be 9. Again, it's not to scale, and I get that. You can now do the Pythagorean Theorem with 9 and a missing variable here being the other leg of that right triangle and 15 being the hypotenuse. When you do that, you get the height here to be 12. And so the height of this cylinder is 12, or the frustum is 12, which means then the height of the cylinder is going to be 6. Again, not to scale, and I totally get that. Okay, so now we have everything except the frustum. So we need to do the volume of the larger cone minus the volume of the smaller cone. So the volume of the larger cone is going to be 1/3 pi r squared and times the height of the larger cone. And so we don't actually know what the height of the larger cone is yet. So what I'm going to do is I'm going to zoom out just a little bit and create another right triangle here that's a little bit nicer to see. So I am going to move this triangle here down here so it's a little bit easier to see. Okay. So we had a radius of 1 and a radius of 10. We had the height being 12. And we had this slant part here being 15, and we didn't know the other two parts. And so we are going to go ahead and solve for a missing portion here. We'll call this one x and maybe this one y. We can set up proportions now. So we are going to use x over x plus 12, so the smaller to the larger, equals, and I'm going to use my radii here now, 1 compared to 10. I'm going to cross multiply and get 10x equals x plus 12. So 9x equals 12. When we divide by 9, we're going to get that x, it's 4/3. And that represents the height of the smaller cone, which means if we add that to 12, that's going to end up being the height of the larger cone. So when we add those two together, we end up with 40/3 being the height of the larger cone. Okay, so if we go over here, we needed that for part B. It was 1/3 pi r squared. Ooh, sorry. So 1/3 pi r squared times the height of the larger cone, which we just got to be 40/3. And we're going to subtract away the smaller cone, which is going to be 1/3 pi r squared times the height of the smaller cone. So if I zoom out just a little bit, I'll be able to see that that height of that smaller cone we found to be 4/3. Okay, so looking at these, here are our different parts. The volume for part A was 2/3 pi r cubed. So the volume for part A, when we plugged everything in, we get 2/3 pi. For part B, we did 1/3 pi r squared h minus 1/3 pi r squared h. When you plug those all in and simplify them, you end up with 444 pi. And so for part C, we did pi r squared h. When you do all of that, you end up with 600 pi. And then for part D, we did pi r squared h divided by 3. And this one's not the nicest, so we're just going to kind of leave it as its nastiness. It's going to end up being 200 root 11 over 3 pi. And so those are each of those individual parts for the volume. So all we need to do is we need to take them and combine them. So when we add all of this together, we end up with a total volume then of 3,976.55 units cubed. That would be our volume. So I believe the problem also asked for surface area. Now that we've found all of the different pieces, surface area should really be a little bit nicer than the volume because we already have all of our information. So let's put this over here, surface area part A, B, C, and D. So the surface area for part A, we are going to do 2 pi r squared for that hemisphere, 2 pi r squared. For part B, we're going to do the lateral area of the bigger cone minus the lateral area of the smaller cone. So the lateral area of the bigger cone is going to be pi RL. And the bigger cone has a radius of 10. Now we do need to know the slant height. So we do have to solve for y. This is one other thing we need to do. So I'm going to zoom into my triangles over here real quick and solve for y. So y is going to be proportionate to 15. At the same rate, 4/3 was proportionate to 12 because those lines are parallel. That is a 4/3. My pen's not working. There we go. Okay, so when you cross multiply and you solve for y, you're going to end up with y being 5/3, which means this entire slant here is going to end up being 16 2/3, or 50/3. Okay, so moving back to our surface area formula, we are doing pi RL of our bigger cone. So we have pi R, we just found our L to be 50/3, minus pi RL in our smaller triangle, or smaller cone. Our radius there was 1, and our slant there was 5/3. Okay, part C. I'm going to move these. So we have A, B. Let's move C down here. Find the surface area for part C. We're looking at the lateral area, which is going to be 2 pi RH. So 2 pi times the radius, which is 10, times the height of the cylinder, which is 6. And then the last part here is part D, which is the cone. So the surface area we want for the cone is just the lateral area, which is going to be pi RL. So pi times 10 times 12. And so with all of these, we're going to end up with a lot of different answers. Part A here gives us 2 pi. Part B is going to end up with 165 pi. Part C is 120 pi. Part D is also 120 pi. So when we combine all of these together, we end up with 407 pi units squared for our total surface area. Thank you very much for listening. I hope this helped.